Working drawings is a very interesting work. Just like you, I've also been in college at some point of time. I always thought working drawing was something to be done because it is a subject and it needs to be delivered. Maybe it is a little better version or higher version of building construction. This is the kind of paradigm with which most of us have studied. But what I'm going to do today is not really talk about how to do working drawings. I'm going to talk to you about a dream which I had and it got fulfilled and the process by which it got fulfilled. Uh, Before I proceed, I want to make a few clarifications to the presentation. Number one, I'm going to show you a project and talk to you about it. But it is in exposed concrete. It is a medium we have explored a lot as a practice. But it does not mean this kind of a process only applies to this kind of a building. So there is something you got to understand. Secondly, the larger goal of this presentation is to bring about the connect between what we call concept design and what we call working drawings. Right now, I believe a huge disconnect exists in the way we look at things, and have seen students copy paste a lot of material in working drawings, and now initially it used to be manual drawings, but now with computers it has become even easier. Trust me, you're not doing any good to yourself when you're doing that. So with these two things, I'd like to talk to you about a dream of mine. Okay. So now any project that we do, it happens in two parts. One, there is a first creation. And number two, there is a second creation. In a class, I would have liked to make it more interactive, but here I'm just going to tell you what is my understanding about it. So first creation is when you actually conceptualize things, and when you design things, and when you take it to a level where it can be actually executed. First creation is usually a more beautiful process because your entire left brain and right brain, your logic as well as your imagination comes into picture, and you try to put all the efforts in imagining something which is not existing. Second creation is about actually building the project. Building the project is more of a management exercise. Once we as architects have completed our job in the first creation, sorry guys, I just need one clarification. Uh, we'll stop the screen right now, or let's do one thing. Can you see the screen which I have been sharing? Just unmute and tell me.
Yes, sir.
Yes,
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 sir.
sir.
Okay. So you seeing the presentation, not me, right? Guys.
Yes, sir.
Okay. Thank you so much. So we'll
Yes,
continue. Okay. So I was talking to you about the first and the second creation. First creation is more about.
sir.
Okay, you can mute yourself now. Yeah. Thank you. So first creation is more about imagining, visualizing, and putting it in detail such that it can be executed. The second one is more of a management exercise where uh, the orders are being followed, the drawings are being followed, the instructions are being followed, specifications are being followed, and there you get your second creation. Please do remember that when we study or when we practice as architects, we are majorly working in only the first creation part. So I'm going to talk to you about one of my favorite projects, my own house. This is in Surat. Me and Saloni designed this house 4 years back, and we moved in 3 years back. The house took exactly 12 months to construct with the furniture, finishes, everything. Which is little fast, I believe, compared to the complexity which was involved. But that was possible only because the first creation was done to the detail. It took 8 months to design everything. So another clarification I want to make at this point of time. So what you're going to see today, the drawings, etc., are done by professionals. It's done after 15, 17 years of experience in the field. So please don't get me wrong. We don't expect this out of you, but the idea is to understand the process. With time, with experience, you would obviously learn how to get things right. But the approach is something I want your antenna uh, to absorb, to catch. Okay? So this site is, so this picture was taken 4 years back. It used to be a ground like this, and this is fascinating what our profession allows us to do. We really convert open ground into beautiful spaces. So the plot size is about 1800 square meters. So this is what we do in college. Till now, in the fourth semester, we always talk about the concept, right? So this house, uh, I'm sorry I didn't show the north, but north is to your left, and this is south. So the whole project is made up of one, two seats facing north, and one, two, and three seats facing the south. Okay? So this is the basic idea behind this, and this is where you enter. So there is a central code, there is a north code, and then there is a south code. So when we converted it into the architectural plan, it started looking like this. Uh, Wherein we can see the C like this, the C like this. This becomes the public block. Public block has basically the formal living, multi-purpose, dining, and kitchen. They all open up like this into the north pole. Similarly, on the other side, the second block is basically a private block. So you can bring like this into the central pole, and you go like this, and this is the bedroom. This is the bedroom, and it has the services, the bathrooms, and the dressing areas. And number 15, at which you see, is the south pole. It's a very simple plan, no jazzy plan, very basic functional plan, trying to respond to the directions. You go on the top, and there is the library, and on the two sides again there are two identical bedrooms, number 2 and 6, and it has its own dressing and the bathroom areas. This number 1 is kind of a small room which you use for storing bags and yoga, and then you can actually walk across into this 9 number, which is a terrace over the living room. So that's how the plan configuration works. These are the, from the north and west. These are the facades. Now, these, as architectural intent, are very clear. In this society, there are no compound walls. So anything which is facing the road, like you can see the west side, is blocked for privacy, and north and south are open because you don't need privacy there because you're opening into your own garden. So this is a response to the context in terms of the design. Here are the sections. We talk to you more about these. But these were done at the architectural stage of design, just like in the semester. Let us say this is the final jury presentation. You can look at it that way. So these are the final plans which we derived sections. And suddenly I jump over to the final product. It looks like this. Just like the plan, it's a very simple building. And you can see there's a clear-cut gap between the two buildings, and there's a glass slit aluminum skylight through that. The next step, whenever you try to start imagining now that the concept design is done and you want to start building, you start thinking about the materials that you're going to use. So we we kind of agreed to a value system that whatever we do, needs to last long. So built to last was an important value, and easy to maintain was another important value because we know that it's not uh, when you make slightly bigger houses, it's so difficult to maintain, it's very difficult to find people to do it. And so when things go wrong, you don't want all the agencies again and again in the house. You do that. Also, we were conscious that we did not want the materials to travel a lot, so we took materials which were available within about 200 kilometers from my house. Is a very important part. So whenever you start working on, you have to finalize your material palette. Some of you might have even done so at the concept stage. Now, this is an important slide. I would like you to look at the dark green box. It says concept, development, construction drawings, and execution. So as architects, we normally deal with these four stages uh, of services. So concept is what you have been doing in these semesters so far in your design studio. Development is the next step. So what do we do in concept design? We work on ideas, we work on materials. Uh, some of you in advanced classes also handle the regulations of the building bylaws. And in real projects, we also look at the budget. So concept design, whenever you do, it needs to take care of these four aspects. Next is the design development stage and then the construction drawing stage. So these are the two stages. These are the two rectangles marked with light green, which is the process which is expected to be done in the working drawing semester. So once you have your concept in place, you go through first the design development process in which you finalize your structural grids, you finalize your finishes, your claddings, your flooring, a lot of material things which needs to be defined. Another part is the constructability. In the design development stage, we normally look at things whether whatever we conceptualized, are they buildable, are they constructible? Sometimes the forms are constructible, the structure is also constructible, but the site may not permit you, the site may be too tight for those kind of machineries to handle, to get into, and it is not constructible. So some sort of design changes come at this stage also to make it constructible. And this is the stage, once this is done, we prepare the first estimate of the plan so that the client is also aware about where the dream is heading, whether you can afford the dream or not. Once that stage is done, the third stage is what we call the construction drawings. So this is more of a stage where one starts looking at how materials come together. What are the junctions? What are the details? And if you dreamt of a very interesting staircase in your project, uh, this is the time when you actually detail it out. Also, number three says make. Make, when I say make, I mean the company or the brand or the product. A lot of times, we need to specify exactly what light fixture you want to use, what sofa you want to use, what kind of doors you want to use, what company, because everything is not generic. For a tube light, you can say I want 40-watt tube light, and you can get Philips, Muslim, etc. But when you talk about certain design focused objects like furniture or uh, things like that, you may want to specify exact make. And again, once this is done, you refine your estimates into a project cost. So these are the two things which is the focus of working drawings. And mind you, this is part of your first creation. This is not something else. This is not a subject. Okay? If we are not equipped to do this, we will never be able to realize our dreams. And the second creation, like it shows, is the execution. In that, you are expected to do the coordination with the consultants, with the site people. If there are issues, you provide the revisions in the construction drawings. You establish parameters for checking the quality of whatever your dream is, and you also figure out and help the project managers in controlling the cost. clients. But if you suggested something and the price is escalated a lot, he may come back to you, the project manager, and he can tell you, "Eh, this is now not fitting the budget. Can you suggest me an alternative material?" Things like that. So there is a second creation part. So I hope you're clear about the first creation. First creation is a seamless project process from concept to construction drawings. આમાંથી થોડોક પાર્ટ પણ તમે ફોકસ નથી કરતા, then you lose control over your project. That is the point I want to emphasize. I hope we are clear on this. Now, to take it further, when we say design development and construction drawings, what are the kind of decisions we are trying to make, or what are the kind of subjects we're trying to cover? So you can read them in light green fonts for these four blocks. So you got to decide your construction materials, your structural system, all that Nehal Bain and Veena Bain have been teaching you. They've been teaching you various materials and various construction systems. So this is the time when it's time to integrate that into that knowledge into your project. In VMC, you've been learning about various flooring materials, I believe, tiles, stones, etc. So those decisions have to be done. Facade is something we are usually obsessed about because it kind of defines the form of or the outlook of your project. So there are a lot of facade systems and facade materials that you need to search and look. See, drawing, it is not about making drawing. It is a lot about having knowledge and information of what exists in this world in terms of products and technologies. And then we are able to integrate that into the projects. Next is the opening system. What kind of openings you want, what kind of weather shades you want, those kind of things will come into place. For doors and windows usually have seen the unbelievable options available now for creating doors and windows in terms of materials, in terms of strength, in terms of security features. So this is where your knowledge about these things will come into play. Then systems. Systems is again more related to things like Windows, how you want to open, whether you want a slider, whether you want an openable system, whether you want doors, how all these integrate with your project. So many systems we use in a project, and the knowledge again comes into picture. What kind of glasses you want to use, how do you want to actually visualize your staircase. In fact, staircase has a lot of technical aspects to be understood. Uh, Once I fell from a staircase while I was climbing in a project, was not designed by us, because the tread's height, tread is the vertical height of every step. It had a variation of 10 mm, 10 mm. Okay. So with the variation of that 10 mm, uh, my I used to climbing in a certain way, and this 10 mm I missed and I fell down. So how to get your staircases right so that you're absolutely correct in tread and risers. How do you want to see the soffit? નીચેથી કેવો દેખાવો જોઈએ staircase? ઉપરથી તો બરાબર છે, but while you're climbing, so even that becomes important. Then a lot of services, technology you need to know to integrate in your project, like air conditioning, plumbing, electrification. Lot of innovation happening all the time. For the last few years, automation is something which has really now spiked up. It has become the necessary part of a project. More so after COVID, because now everything is about data. You need data for everything. Uh, like the Arogya Setu app, see how government is trying to track things with that. So automation has become very important. So it is not something you have an option to know or not. Better know it if you want to actually build. Horticulture. Horticulture is the technical aspects of landscape. What plant, કેટલી light જોઈએ, how much water does it need, what would it look like, what kind of leaves would it have, how many months in a year would it have leaves and flowers. So those kind of things are also the design aspects. And as you go further to the detailing, obviously the furniture parts, all your furnishings, floor, curtains, blinds, all this come into picture. So this is the overall picture that you are getting into as professionals. You are just in your fifth semester. It's very early days, but it's important to have the paradigm that uh, architecture is not only about concept design. If you cannot detail it out, I mean, if you cannot detail it out with passion, you are only half the design. With that, I'll move forward. I will ask if there are questions or not, but I think you can post it on the chat box. This is very important understanding to have according to me. So out of these four, in these 4 weeks, what we targeted is to focus on structure, enclosure, utilities, and statements. This is an incomplete list of what all information and knowledge you need to have, but you have the whole life in front of you if you get your approach right. So I'm going to talk about the same 4 things which you will be learning in the 4 weeks from today. Um, so starting with structure. Now, once your concept is done, then you start thinking, okay, how will a person live inside? Any Jarur Suhas, what will be his needs? So in that case, me and Saloni must establish our needs. When it comes to structure, what are our needs? So avoid any kind of offsets of structural members between walls. Everything is structural in a concrete house. So, like you see, especially for people who are living in apartments, if you look at the ceiling, you'll see an offset of the beam in the wall. Okay? Because the beam is bigger and the wall is narrow. Ideally, you don't like it, and then to hide it, you do all kind of treatments with plaster of Paris or paneling or something to hide that. So this was our need, which was established right from the beginning. Second is my flooring and skirting should not visually cut the module visually. So I'll explain what I mean. Any concrete house, if you try to understand how the casting is done, it is done layer by layer. You cannot construct the whole house or the whole floor at the same time. So in a nana layers like units one. So you pour one line, and then you put your shuttering on top, and then you again pour the second line, third line, fourth line, and so on and so forth. So concrete house dimensions have to be in multiple of this module. Otherwise, you'll end up cutting your shuttering plates uh, now and then. So when you do that, when you put a flooring per module બનાવો છો અને પછી ઉપર flooring કરીએ છીએ. So the flooring takes about 75 to 80 mm of space. So visually that module gets cut. So how do we ensure that after the flooring is done, I see the whole module? This part sees clear logic in deciding the module size for the house. I think if you want to work in concrete, I would rate this is the most important understanding to have uh, to design the concrete house. Then once the modules are sorted, we thought that those, you remember the C's I was talking about, the 2C walls facing the north and 3C walls facing the south. So how do we create interest by use of textures in the C without getting overboard or tangled? So that is the next need which we establish, that we need to work on the textures. And the fifth part is also always important, that when you do such a house, you also want to keep a tab on the cost. So uh, how do you design a structure which is economical? I'm sure that after 18, 19 years of practice, I'm not able to design this structure because it is not my job. But by what I've learned in my college, like you probably would learn or would have learned concrete design uh, in the college in structures. You should have that basic understanding about what you can tell your consultant and how you can say, right? Tell me more about it when we go further. Oh, so this is the kind of drawing your project will become when you try to put columns into it. Now, what I want you to see here is the width of the column. I have zoomed up a part of it on the right. I hope you are able to read it. So, what is common is the 200 dimension. So, we have ensured that all the walls are 200 in size, all the beams are 200 in size. And this wall thickness again uh, has to be multiple, divisible perfectly by the module size. So this was an important process we did. This was a to and fro process with the structural designer, but we kept our need alive that we wanted only in 200 So I'm just zooming up a part of that. Uh, if you can see here on the image on the right, uh, you'll see C22 at the top, the column. C22, the size says 200 by 1200 Now try to find the same column here. Okay. So it's the one next to the 19th and the 20th thread in the staircase, C22. So all the columns are marked in the drawing. So though everything is RCC, there is a structural part and then there is a non-structural part. Okay. I'll be sharing the presentation for people who need, so I'll not give you a lot of time. I just want you to understand the concept. You can obviously study this later. So that's what the section looks like. So you can see here, there are no beam offsets. I want you to see that. Everything is clean. You can see the modules. And this is what the space looks like. You can see the 200 grids everywhere. Okay. This is the north elevation. I would like to talk here about how the modules have been designed. So there are two kinds of modules in the house. Uh, you can see there it is written block A. I'm referring to the elevation on the top. The front part in the north says block A, and there is a block C and D in the background. Block C and D, you can read in purple the dimensions. So it is 1200 by 400 grid. Okay, I hope that is very clear. What is not clear here is what is the grid size of block A. Block A is not in the multiple of 1200. Okay? There's a reason to it. We come to the reason later. But you can see the whole house is following this particular grid. So if my grid is 400 in height, obviously my sill, my lintel, everything follows that. You can see that. So the same area, again, so I'm zoomed in the same area, and you can see the grid size written in green color. Okay. Try to have a look at the legend at the bottom right corner. So legends are very important part of, any drawing. They are like your alphabets. Without alphabets, you won't be able to read your drawing. So it's very important to understand that. That's a zoom section of the same part. Now here, I was talking to you about the floor thickness. Right? So if you can see, uh, the dark thick black line, it shows me the plinth slab line. Whenever you make a building, the ground floor slab is called the plinth, on which your building is put up. So the plinth line is shown in in a thick black line. And above that, in cyan, you can see the light blue lines. So there's a small offset after which my grade starts. So equivalent to the floor thickness, we started the grade after that. So this ensures that after my flooring is done, the grade is not cut. Uh, I hope I am clear. You can refer it again. It's very apparent that I've in fact zoomed it on the right bottom image to show that. Another thing what I would like you to notice is that our terraces need waterproofing. So when you do waterproofing, it requires a certain thickness, which is shown here in purple. So even that thickness has to be considered whenever you are making your grid sizes. So this is the two things I wanted to show you in this slide. Now let's talk about the variations in textures. You can see block A, B, C and D written in the elevation on the top. Okay, that's the elevation on the west side or the road side, the blank walls. So all the C's are visible from here. So the grid size remains the same, 1200 by 400, and there's a variation in size, heights of this building. Again, it's in the multiple of 400 mm. And now look at the legend. Block A, it says exposed RCC, smooth ply finish. Block B is texture finish. Block C is texture finish. Block D is smooth ply finish. Block E is again smooth ply finish. So it's pre-decided that these two blocks B and C are going to be in texture, which in our case we have taken imprints of pine wood on the walls, whereas block A, B, and E they are in smooth finish in planning. So this is the next need which we had established, which we are trying to satisfy. Now that obviously needs to be reflected in the plan, otherwise the contractor would not understand. So all that is in red is in smooth light finish, and all that is in blue is in wooden finish. Okay? So again, there's a legend at the bottom right, which you can look for. Another thing which you can see here now, which was not there before, is the ceiling patterns. So you don't just need to decide the walls, but you also need to figure out how would the pattern of shuttering look in the ceiling. So the lines in magenta and cyan, they show the reflected ceiling plan of these respective places. So that's what it looks like after it's done. I believe you can see the wooden entrance, the block B and C. It's apparent because they are smaller strips. Wood is not available 400 mm wide. So we've taken 200 multiples of 200 mm to do the texture point. So this is the elevation drawn before that, and this is what the way it is built. Now comes in the structural designer, the consultant. Uh, you don't have the luxury as students to deal with the consultant, but these are the kind of drawings we make. We will send you and say approve this. So your obvious question is, what is the steel? The reinforcement steel consumption is one of an important determinant of the cost for RCC structure. Right? So he told me that the cost consumption of steel is coming to about 6.5 kg per square feet, which if you convert it is approximately uh, 70 kg per square meter. Uh, Now that makes it very expensive. 1 kg of steel is about 50 rupees, and for a 7,000 square feet house, for every kg, I'm adding about 3.5 lakh to the house, which I thought, how can I save it? So we worked back and forth with the structural designers and focused uh, on all the non-structural RCC members to reduce the steel, and we did it very well, and we could bring it down to about 5 kg. So we could save about 1.5 kg of steel, wherein almost 5.5 lakh of rupees were saved by this understanding. And your clients will appreciate this if you are able to do it. So to sum up, what do you do in structure drawing? So why structure important? So the concerns are with the aesthetics. You are worried about what your project will look like. You don't want unnecessary structural members. You also want to consider the safety of the inhabitants. You want to look at economy, and you're also looking at speed. Faster the building is able to be constructed, the it is for everyone, the user, the designer, the builder. So what are the tools that you have as designers? So dimensioning systems like modules, etc., is something which is there in your hand. What is the difference between the lintel height of 2.2 meters and 2.5 meters? All those things will depend on your sensibility as a designer. Next is the openings. How to create openings is within your hand. What kind of systems you propose for various products is in your hand, what kind of finishing you want to use. So all these things will be reflected in your drawings. The tools is something which you use to take care of your concern. Right? And obviously, you need to have some values to make decisions. There are hundreds and thousands of products and solutions available for everything. So if you define your values, then it will act as a filter for you to filter out your decision. So for me, cost was a decision, maintenance was a decision. The life of the product was also a very important decision. So there are places where I've spent much more to get a very long life. And obviously, visual appeal, the aesthetic part, which is important as a value. So to take care of structure, these are the kind of drawings you will need to make. You need site level plans, print marking, line up. I'm sure your teachers, as you go ahead, will be able to show you more of this. Unit level plans for all floors. So there's a different plan for civil working, different plan for grids, shelving pattern, etc. I tried to show you in parts here. Then there are part plans needed, sections, elevations, and structural drawings. So this kind of takes care of all the structure related issues. So we're done with the structure.